Good afternoon, students. So this is Mr. Chen. Welcome to my master class once again. And this one is for pre-calculus, James Stewart, sections 5.3. It's about the graph of sine and cosines. So besides the graph, the analytic of the graph, so also we'll talk about the word problem, the way to apply those kind of model, cosine and sine curve, for the real life situation. Okay, so you'll see that in a minute. Okay, so let's just get some kind of refresh from what we did from trig last year. Okay, so again, this one 4.5, which is the same as sections 5.3. So the graph of the form of y equals a times sine of bx minus c plus d, or y equals a cosine of bx minus c plus d. So the one that we were talking about last year is quite similar to the structure like this, but instead it's like y equals a times sine of b, and then times x minus h plus k. So this one is just like the non-factor form. Again, the value of b is just showing that the scalar for the horizontal stretching and shrinking. Okay? And again, a is always the amplitude, absolute value of a, and then period, 2 pi over b. Okay? So in the same Cartesian plane, sketch the graph of y equals sine of x, sine of 2x, sine of x over 2. It's just showing that, the period, the differences of the period. So started with the first one, the period. So from 0 to 2 pi. Okay, so that means it's just consider a roller coaster. Okay, so that's just the parent function. So this one's supposed to be all the way to 1. Okay, let me just fix that. Okay, like this. And then the other one, the period, then that'll be considered 2 pi over 2, which is just pi. So just making the graphs smaller. Okay, so let's use different color. Okay, so, and then the other one, the value b, so 1/2. So 2 pi over 1/2, which is 4 pi. So just make it wider. Okay, so the other one, 1/2 pi, sine of x over 2. Okay, like this. Okay, so grab one cycle, label the relative extrema. Okay, so the point, the maximum, minimum. So just find out what those points are. Okay, so you guys can do that. State the domain, the range, also if that's one cycle. So the domain for the parent graph, 0 to 2 pi, if that's one cycle. And then the other one, so for the 2x, so that one is from 0 to pi. And then for the one that's 1/2 x, sine of 1/2 x, so the domain would be 4 pi. Okay, so now what about something that looks kind of difficult? So you find out things that's kind of difficult, so always try to find a way to simplify it first. So graph the equation of cosine of x. We do know that cosine of x is just a bell curve. So start it at 1, and then it goes all the way down to 0 at pi over 2, and then at pi, it goes all the way down to -1. 3 pi over 2 goes back to 0. 2 pi goes all the way back to 1. So just like a normal upside down bell curve. And then the other one, it's a sine of x minus cosine square of x minus sine square of x. Well, this one you want to extend it all the way to 3 pi. So you want to keep going. Like that for the parent graph. And then for that y equals sine of x minus cosine square of x minus sine square of x. So first thing that you can do, simplify it. So factor out that -1. So we do have cosine square of x plus sine square of x. Then that'd be 1. So it's just sine of x minus 1. So basically this one, it just shows that the parent graph, shows the parent graph of sine of x with the vertical translation, 1 unit down. So 1 unit down, so started at 0, so it's 1 unit down here. So again, use different color. And then Back to the top here. At pi over 2, then that'd be 1. Back to the top, it's actually all the way to 2, excuse me. And then over here at pi. Okay, so it goes this way. Well, pi over 2, so sine of pi over 2, then that's 1. 1 minus 1, that's 0. So it's 1 unit down, shifted. So back to 0 here. And then the next position at pi. So sine of pi, that's 0. 0 minus 1, negative 1. And then 3 pi over 2. So negative 1 minus 1, negative 2. And then sine of 2 pi, 0 minus 1, negative 1. So again, it's being shifted 1 unit down for the sine curve. So still consider a roller coaster. And then keep going. So it goes back to 0 and goes all the way back down. Okay, so now let's see what else that we got for this one. So by using the graph from part A, state the solutions of the equation. So sine of x minus 1 equals cosine of x. Okay, so again, simplifying that, it's the same equation. So you want to find out the point where they intersect. So the point where they intersect, then that'll be those 2 points. Okay, so the one that I pointing at right now. So then that'll be what? Pi over 2. And then pi. And also it could be what? This one here at pi over 2. So 2 pi plus pi over 2, 5 pi over 2. And then 3 pi. Okay, so solve the equation algebraically. So we can solve for the equation algebraically. So sine of x minus 1 equals cosine of x. So just bring that sine of x, cosine of x together. So in order to get that as 1, so this one, make sure that we do have the exact same ratio. Or one is bigger than the other. Okay, we can do it that way. Another way that we can do it, let's see. We try to square both sides. So try to square this one on both sides. So what we got here, it's sine square of x minus 2 sine x cosine x plus cosine square of x. So that equals 1. So sine square of x plus cosine square of x, then that'd be 1. Minus 2 sine square of x cosine of x. And then 1 and 1 got cancelled. So that means negative 2 sine x cosine x equals 0. Okay, so in order to have that one, so either sine of x equals 0 or cosine of x equals 0. Okay, so in order to have those, so that would be considered pi over 2. Well, this one could be pi. It could be, well, the one that we have right here could be pi and 3 pi. And then over here it could be pi over 2. And also it could be 3 pi over 2. There are a lot of solution here for this one. Okay. Okay, so pi, 3 pi over 2. Okay, so check that. Cosine of 3 pi over 2, then that's 0. So 0. But somehow this one it doesn't show that 3 pi over 2. Okay, so now for what value of x is sine of x minus 1 greater than cosine of x? From 0 to 3 pi. So this one is showing that the value of x is that sine of x minus 1. So that means you want to find out the part of the region that's sine of x minus 1. It's greater than cosine of x. So then that'll be this one right here. Above, less, smaller. So this region. So then that would be from 5 pi over 2 to 3 pi. Okay, 5 pi over 2 to 3 pi. Okay, so now let's see what else. So graph the function, state the domain, range, amplitude, period, graph 2 cycles. So similar to what we did last year, but this one you can always rewrite it, ultimate form. So y equals -2, cosine of -2x plus pi plus 1. And also take out that -2. So it's -2 cosine of -2 times x. Or just put in 2 because that shows the reflection. And by the way, the negative, you can put it out because that one is an even function. So let's show the word to simplify that. So take out -2 first. So we got x minus pi over 2 and then plus 1. So what we got here, so it's -2. Again, cosine of negative theta is the same as cosine of theta. So it's cosine of 2 times x minus pi over 2 and then plus 1. So the value of a, so which is 2, but it's reflected over the x-axis, okay? So a is 2, shows the reflection over the x-axis. And then the value of b is 2, so period, 2 pi over 2, which is pi. And then the horizontal phase shift is what? Pi over 2. And then k, which is what? 1. But now let me take this one to the new page. We can do the one cycle test. Certainly you can do the one cycle test. You know what? Let's just put it right here. So try to do the one cycle test. You'll see that the initial position and the final positions of the boundary. So where to start it and where to finish with the one cycle of the graph. So cosine, the one cycle test is always from 0 to 2 pi. And where 0 and 2 pi, they're both included. So putting the quantity, so we got 2 times x minus pi over 2 less than or equal to 2 pi. Divided by 2 first, so we got 0 is less than or equal to x minus pi over 2 is less than or equal to pi. And then add pi over 2 each side, so pi over 2 is less than or equal to x. It's less than or equal to pi plus pi over 2, which is 3 pi over 2. So for the one cycle, so this one, it takes care of the phase shift. It takes care of the period. It shows you where you started with the graph and where you end with the one cycle of the graph. So pi over 2 is right over here. And then 3 pi over 2 is over here. Now keep that in mind. This one, the amplitude is 2. And also it shows the vertical translation, which is 1. So normally without the negative reflection, so we started at 2. But due to the negative reflection, so we started at -2 plus 1. So -2 plus 1, then that would be -1. So that means we started right here. And then the next position is supposed to be going to 0. But due to that, the vertical translation, so this one is up 1. Okay, up 1. And then the next one's supposed to be 2. But due to the vertical translation, so 2 plus 1, then that'll be 3. At pi. Again, it's all reflected. And then the rest of this, symmetrical. Okay, so all symmetrical. This one goes all the way down to here. Okay, so it's going this way. Like that. And but the thing is that this one you want to sketch graph, well, what is it? 2 cycles. So 2 cycle, this one just symmetrical. Okay, going this way. So all you need to do is just make it symmetrical. And showing that the line of symmetry with respect to the y-axis. Okay, so one cycle. Here's another cycle. So it's like an M curve. Okay, so now let's see what else that we have right here. Write the transformation for each function. So again, this one just describe it. So y equals negative 3 sine of x minus 3 over 5 plus 2. Compare and contrast. So a sine of capital B x minus h plus k. So transformation, this one you can just say that it's, well, the graph with the amplitude of 3. Okay, so with the amplitude it's 3. With the period, then that'll be 2 pi over 1, which is 2 pi. And then with the horizontal phase shift, 3 over 5 unit to the right. And then with 2, the value of k, 2 unit up. Okay, so that's how you describe the transformation. So the other one is quite similar, but you might want to factor it first. So 3 cosine of pi over 2, take that out, and then x minus, so this one's pi over 4, so 2 pi over 4, which is pi over 2. So describe that, the value of a, b, the period, h, and k. Okay, so just finish the rest of those. Quite similar to what we did here. On the same Cartesian plane graph, f of x equals sine of x, g of x equals f of absolute value of x, and then h of x, absolute value of f of x, where negative 2 pi to 2 pi. So basically just typing that on the decimals, or just do that on the TI. So pretty easy, that shows what that is. Okay, let's do it on the TI. Okay, so you can just do it manually. So started off with sine of x, but one thing you need to clarify here, make sure that the mole going to be considered radian, because that the calculator doesn't recognize the high number for the degree. Okay, so just make sure that it's in radian, this small unit. So started with that, the parent function, sine of x, obviously that's a roller coaster. And then also change the window, so instead of all the way from 0 to 1000, so let's put into the standard scale. So 0 to 2 pi. Okay, let's just make sure that what we got for the instruction here, it's negative 2 pi to 2 pi, excuse me. So negative 2 pi to 2 pi. So negative 2 pi, so x min, negative 2 pi. Again, negative is the one down here, you don't want to use the minus. So negative 2 pi, second pi. And then the scale, just keep it that way. Y min, so let's say that it's negative 2. And then y max, let's put in 2. Just want to make that the y-axis bigger. And then the rest of that, just keep it as the way we want. And then y equals y2, so let's find out what that is. So y2, let's put in f of absolute value of x. So f of absolute value of x. Okay, so that means it's sine of absolute value of x. So making sure that this one. Yeah, so sine of absolute value of x. So sine, absolute value, so math, number, ABS, x. And then for y3, so we want to put in, the other one, I need to finish that with the closed parentheses. Otherwise, it might be considered a syntax. Okay, so that's not the way I want. I want to put a parentheses right after the absolute value. Okay, close parentheses. And then for the other one, it's just absolute value of sine of x. So math, number, ABS. Okay, one more time. So math, number, ABS. So sine of x, close parentheses. Okay, so you see that the different graph right here, 3 of those. The parent graph, the one with the absolute value inside, and then the absolute value outside the whole function. Okay. Okay, so now let's see what else that we got right here. So find the domain of the range of each function without graphing it and without the use of a calculator. So this one, you might be wondering, it's kind of difficult, but the thing is that it's all about the analysis, Because that for sine and cosine, they always consider the continuous functions from negative infinity to infinity. So continuous function, that means there's no gap, there's no hole, there's no jump, and there's no VA right in between. Okay, so we'll talk about more like that in calculus. So that means the domain for the quantity, it's always considered from negative infinity to infinity. So we got 1 minus x squared. So what is that? It's a polynomial. So basically this one, there's no restriction. So we can say that this one is satisfied that from negative infinity to infinity. So what that means is that it doesn't matter what kind of number that you put in here, all the real number, it's always, you can define the solution. So for the domain, it's all real number. But what about the range? Well, the range here, it's, well, it looks like the amplitude is 2, but it's being bounded from 2 and 2. Negative 2, positive 2. So the smallest amplitude here, then that'll be negative 2. So for the range, so we got to be very careful. So plus minus 2, so negative 2 plus 2, then that'll be 0. Bracket, okay? And then close bracket, so 2 plus 2, then that'll be 4. Okay? So it's all about the matter of the value of A and the vertical translation. Now, what about for B? Like this one, it's what? It's a rational functions. So a lot of people might be wondering, well, we need to find out the restrictions, the denominator, the VA. But according to what we know, 2 to the power of any kind of variable, it's, well, what is that? It's an exponential equation. So there's no 0 for this. So this one is getting close to 0, probably. But somehow, the constant, it's always what? 3. So there's no restrictions for the denominator. So that means there's no VA. Another thing that we notice, x. So x could be any real number. So there's no restrictions, and also x can be any real number. So that means this one, it's always considered negative infinity to infinity. So again, the whole picture here, it's just a rational functions. But somehow the denominator, it won't be 0. If you try to set it equal to 0, it won't work, okay? Because that 2 to the power of cosine of x equals negative 3. But you take the natural log both sides, it doesn't work. Because there's no such thing natural log of negative 3. So therefore, there's no restriction. Domain's always negative infinity to infinity. But what about the range? So think about this way. So this number is getting bigger and bigger and bigger. Okay, so 2 to the power, 2 to a very small number is getting to like what? It's like infinity, right? And then infinity plus 3, it's always what? Infinity. But 1 over infinity, it's getting close to 0. So this one, you probably want to state that it's from 0, anywhere that's greater than 0, all the way to infinity. Because this number, it's always greater than 0. Okay? 2 to the power of cosine of x, exponential growth. And then plus that 3, and not a constant, so make sure that it's going to be positive. So the range is from 0 to infinity. And then what about the rest of this? Cosine of x, again, x, there's no restrictions, so domain, it's always negative infinity to infinity. And somehow this one, it makes things that could be either 0. If that's 0, then that means the max would be considered 2. If this number is negative, but negative times the quantities, negative quantity squared, it's always positive. Positive times negative, negative. So somehow, so this one has a possible chance to be considered 0. Okay? Because that this number would be considered very close to each other. Negative 2 plus 2, then that's 0. But what about for the max? So the max right here, so I would say that is 2. So the range here, so this one would be saying that from 0 to 2. Okay? So again, if this number is considered 1, so that means this one would be considered negative 2. So negative 2 plus 2 is 0. And then if this number is 0, the smallest, well, probably the smallest number, and then 0 times negative 2, 0, 0 plus 2, 2. So then that'd be the range. Okay, so now let's see what else. And the rest of this, those are the word problem. Okay, so we'll talk about that for the next part of the video. Okay, so we got number 7, 8, 9, 10, and 11. Okay, so I'll see you guys next time for the second half of the video. So thank you for watching it. I'll see you guys next time.